Hello, welcome. This is Luebcke-Eckstein. I haven't done one of these videos in a while, but I thought I would do relatively quick one here. Hopefully, it's relatively quick. I just wanted to give you an idea, um, visually, of the differences in some of the models leading up to this next cold air coming in and possibly chances of some lowland snow. I'm gonna actually go to another one here that I was gonna show you first. So this is the European model from about a week ago, January 16th, and I just wanted to show you basically how this whole pattern uh, has evolved. So some of you may have heard in eastern Siberia, it was 80 degrees below zero, lots of cold air that moved into eastern uh, Siberia this past week. So you contrast that cold air with this warm air on the south off of the coast of Asia, and you get an extratropical low cyclone that developed over that temperature boundary and started to intensify all the way over here in the western Pacific near off the off the off the Russian and Japan coast. And I apologize. Um, I'm I'm a little sick, so uh, hopefully my coughing doesn't bother you too much. Anyway, when we get some lows intensifying over there in the western Pacific, they start pulling warm air up to the east of it, and they tend to track a little more toward the northeast as instead of the east, and so you get um, and so you get this warm air building north as you saw when I went through there, that low track there, it pulled up this warm air, and we get this ridge of high pressure on the east side of those lows. So this is what happened here recently. This was the European model forecast from a week ago for this past Thursday. So if I go forward in time up to about the current time, you see that ridge built and then another um, low intensified behind it, and I'm just going slowly until I get to this morning. So this is this morning at 12Z January 23rd. So this was a week ago forecast for today. It was actually pretty accurate. Here's a ridge over the west coast. Now I'm going to go to what it currently looks like, and that is on these four maps. And so, I mean, it is a little different, obviously, you can see, but these are four different models. The upper left is the US model, called GFS. The upper right is the European model. The lower left is the Canadian model, and the lower right is actually a model from Germany. It's called the Icon model. And I'm putting it on here because it also goes out. It goes about 180 hours. The European and the Canadian go about 240 hours to 10 days, and um, the U.S. model goes out 16 days, 384 hours. But anyway, all of them, these are all valid for this morning, so they're all going to look very similar, um, because they're all basically analysis from this morning. But you see on the GFS model, the upper right, this ridge isn't as strong. You tell that by this orange area isn't as big as those others. Um, isn't as large. I'm just making sure that the scale is the same. It is approximately the same. This one was actually a little slightly bigger, so I'm making it a little smaller. And all right. So anyway, you see that the U.S. model doesn't have this ridge as strong as the others. It's close. It's just not as strong as the others, and that tends to happen on the U.S. model. It tends to have weaker ridges, and the other models tend to be a little stronger and a little more accurate. So these two on the left both come from Europe, uh, the European and the German models on the right, and then the left side from North America, the U.S. model on top, and the Canadian model on the bottom. So anyway, this is actually an analysis. So and now I'm showing, like the last one, which is I showed the Pacific Ocean. Now I'm showing North America. So here's Alaska. Up here, the western coast of the United States, and then into Mexico down here. So you see Washington and Oregon are right here. California is down here. All right. Just to give you some reference points. This is what the atmosphere looked like this morning. I'm going to advance each model. I don't have a subscription to a site that lets me hit one key and all 4 maps advance at the same time. So you'll have to excuse me because a little bit as I manually go through each map to advance it. But here's a forecast. So I'm going to go 24 hours in advance for each one. And I need to go up slightly. Yeah, just make sure that I am at 24 hours on some of these. Okay, so the European upper right. Okay, so there's 24-hour forecast right there. And then the Canadian model down the lower left, and the German model in the lower right. Okay, so this is the forecast for 24 hours on all 4. We see on the German model in the lower right, the European model in the upper right, and the Canadian model in the lower right, that stronger ridge with a orange color still poking northeast. GFS is weaker with it. It's not as warm. It's not as strong with that ridge. Again, that tends to happen with the U.S. model, and that's one reason why the U.S. model sometimes is as good in forecasting. So I'm gonna advance more and see how that affects the weather pattern. Now these are forecasts from this morning, as I mentioned. So I haven't actually looked at all these forecasts yet. These are for what we call the 12Z models, which is 4 o'clock. Sorry, yeah, 4 o'clock a.m. here, noon in London. On here on Monday. So this is now a forecast for early Wednesday morning. And one thing that we're watching is this low pressure out here and the upper level trough. When I say upper level trough, it's basically this cold air here that is moving south, and we get this low pressure that develops on the eastern side of it as wind at upper levels starts to spread apart to get rising air and a low pressure system that develops. We're also watching this ridge here, which on all 4 models you see is basically in the same place over the west coast of North America. We're going to be on the eastern side of it, so we're going to have the sinking air, low level inversions. We might have some air stagnation advisories, possibly trapping some low clouds, especially in the morning on some days here along the west coast. Let's go forward a little bit here. Let's go out to 72 hours, which will bring us to early Thursday morning, 4 a.m. Thursday morning on the west coast. And again, I have to do each one individually here. So we see here on all 4 models the pattern's still generally the same. This ridge re-strengthens, although on the U.S. model in the upper left corner, it's not as strong as the other 3, which again is not surprising. But the other 3 models, in the upper right here, lower right, and lower left, the European, German, and Canadian models all look very similar in the forecasting of this ridge. The U.S. model is just a little bit weaker. It's not as warm, and it has more cooler air extending from this trough to the west, down to the south of that ridge. You see a little bit here in the Canadian model in the lower right, left, in the European model in the upper right, and possibly the German model. You don't see that much in the German model, but it probably is a little bit there. Just you don't see the yellow color, but it's not as strong of troughing cooler air that moves as moving southeast as in the U.S. model. So as a result, partly as a result, this cooler air that's actually starting to cut off here in the U.S. model is a little stronger than it is in the other models. All right, let's go forward another 24 hours. This brings us to early Friday morning. And at this point, there you go, no, wait there. So at this point, we're starting to see our first batch of cooler air that moved over the top of this ridge. And at this point, we'll be located somewhere around Vancouver, British Columbia. So you see a little bit in the European model here, German model, not as pronounced in the Canadian model. You see some of this cooler air that comes underneath that ridge, and is basically there's some weak crossing connection down to the south of that ridge. You don't see it as much in the German model, but you see it, the European Canadian look about the same, but it's most pronounced in the U.S. model. And again, U.S. model that's partly because the U.S. model is a lot weaker with that ridge. Here, you don't see the orange colors anymore. On the other three models, you see this big area of orange color. So, which means these other three models have a stronger ridge. European, German, and the Canadian model. Again, that's typical, but that can affect the weather coming up here. So on Friday, what happens on Friday is this first batch of cooler air comes through, and you kind of saw that as I went through here. It's really not that much cooler air. It would still be rain in the lower levels, but we could have some low level rainfall with that. I will get more to that later here. But Saturday is when you start seeing some of the differences that are caused by the strength of that ridge. So the European model, here's that ridge. German model, lower right, here's that ridge. In the Canadian model on the lower left, here's that ridge, still left over. In the U.S. model on the upper right, the upper left, there's a bunch of it left. You don't see any of those orange colors anymore. It's a lot weaker. That upper level low to the northwest has cut off, is located a lot further southeast than the other models. If I was to circle that same area on the other models, it's right there, it's right there, and it's right here. So you can see that the other three models are a lot stronger with that ridge, which prevents that low from moving further south and east. So this is one reason why I usually like to discount the U.S. model when it comes to these ridges, because it's usually different than everything else that we see on all the other models. That's necessarily that's wrong, but it's usually different. That's really sad. And there you go. All right, so let's look at this feature right here. So this is some cold air that's going to start coming into the northwest. This is early Saturday morning at 4 a.m. And we see this lobe of cold air is trying to move southeast. Now, one thing that kind of stands out here is that this light blue color is mostly over land, which means at this moment might be mostly dry. In the Canadian model, it starts to bring a little bit over water here. But what we need is cold air to come. What we need for lowland snow is that cold air to come a little bit over water, so we get moisture into the northwest on top of that cold air coming in from the northeast at low levels through the Fraser River Gap and the Columbia River Gap. So let's go forward a little bit. I'm going to go to 10 p.m. on Saturday evening. which is 6 a.m. in London times. That's when you see these times upper left. 6 on Sunday means 6 a.m. in London on Sunday morning. It's 10 p.m. here on the West Coast. Now you're starting to see the European has this low over water. The um, Canadian model has this low over water. Both of these are almost due west of Astoria Seaside in northwest Oregon. The GFS has this little low feature, I don't know if you can see the little circle, right around the coast there of northwest Oregon. The German model is a little bit, has a tiny little one, it's hard to tell from there. But if we get some development off the Oregon coast on the leading edge of this cold air that moves over that moves over the ocean, we could see some snow here at low levels if it gets cold enough Saturday night into early Sunday morning. So I'll look at we'll go through the forecast of precipitation here in a little bit and see what these actually do. But looking at the ridges again to our west, European um, and the Canadian are the strongest. The German is the next strongest, and on the U.S. model, that ridge is pretty much gone, almost just a little bit of it. So how does that affect our weather coming up? Well, let's see if we go through. Trying to figure out a good time to go to here. If we go to early Monday morning at 4 a.m. Monday morning, let's try that. Now this is Monday morning, January 30th. Now, if you look at the Canadian model still keeps that ridge, um, moves that moves that cold air with up level trough down into Northern California, but it keeps that big ridge off to the west, which could keep um, cold systems coming down to the south. Now, if it's too strong, these cold systems that come off to the east could go off. Sorry, come from the north could go off to our east, and we would remain drier. This is where we start seeing some of these big model differences. The German model still has this ridge here, and still keeps cold air into the northwest, as opposed to a little further south with Canadian model down here in the lower left corner. The European model keeps the ridge. It's a little weaker. It does move that colder air through fairly quickly into California, just like the Canadian model does. The European and the Canadian model tend to be fairly similar sometimes in terms of how fast it can progress that cold air through the northwest. Like I said, the German model still has the northwest into cold air. The U.S. model is the outlier here. And that's because it basically has that ridge completely broken down now. So that cold air has now on the U.S. model. I'm gonna go back actually. I'm gonna just go to the upper left, go back and forth, and you see that cold air on the U.S. model um, passes through and just moves off to the east. On the Canadian and the European, it basically moves south. On the German, it moves south into or northwest, and just kind of stays there by this point. But on the U.S. model, this low in the Pacific that was cut off from the flow before is starting to move east and is forcing that cold air to move east, and it brings in onshore flow a little faster than the other models do. All right, I'm gonna go to here, just go 12 hours to 4 p.m. on Monday, and I'm doing this because the German model here on the lower right only goes out to 180 hours, which is 7.5 days, I believe. And it still has the northwest firmly in this cold air. The German model is actually not a bad model at all. It's fairly high resolution, which is one reason why it only goes out to 180 hours. But for a model that goes out that far, it's fairly high resolution. Um, it's not always perfect, of course, no model is, but it still keeps that ridge and it keeps the northwest in some of that cooler flow. Now, the Canadian model in the lower left cuts off some of that cold air just off of San Francisco. The European model starts to weaken that cold air and move a little bit further east. Now, of course, once that cold air moves into California, it's not going to be as cold as it is up to the north. And then the GFS in the upper left is still out to lunch. And this is one effect that you see of those very small differences in the very short term. You know, you saw that very small difference in how strong or weak that ridge is off the west coast makes a big difference in how the weather evolves. You know, once you get out 3, 4, 5, 6, 7, in this case 7.5 days. So um, the you see this ridge still on the other three models. It's a little weaker than European. It's a little stronger on the Canadian model, but it's basically non-existent on the U.S. model now. And the U.S. model wants to bring us more into onshore flow here, warm it up really quickly as that cold air just all moves off to the east. Let's see. So beyond this, I'm going to go ahead and minimize this one in the lower right because that one doesn't go out any further. So beyond that, of course, now we're starting to get into sometimes what we call fantasy land because of those small errors in the short term affecting our weather in the long term. Now this is a little different than last night. Um, Last night's model runs, and this is how fast they can change too. On both the European and the Canadian model, brought some of this colder air down further south into the northwest uh, by this time. This is now Monday night, or sorry, Monday night, early Tuesday morning actually. Next week on January 31st, and now they keep it a little further north. And my guess, I haven't looked at this yet, but my guess is because of this and because of this weakening ridge, like in the European model here, because of this weakening ridge, some of this cold air may just spread out westward here. The U.S. model is all onshore flow now. Now, if this U.S. model is right in the upper left corner here, and we still have some cold air lingering at the surface, it could spread some freezing rain over the northwest or some snow if there's still some lingering cold air at the surface and we get some moisture that comes in above it. So I'm just going to go through these really quickly now from here on out. So the European on the upper right, I am, and yes, it basically does um, spread out that colder air to the east as that um, warm ridge basically gets cut off to the north, and then we get into another ridge to the south here. All right, and that's the end of the European model. The Canadian model in the lower left basically does the same thing, and then the U.S. model in the upper right here just keeps us just starts moving some um, weather systems in from the Pacific, ends any kind of onshore flow. So this morning's models actually give us a slight chance of some freezing rain. Sorry, I'm trying to open these windows. Slight chance of some snow on Saturday night, and maybe a little bit next week if we get some marine air some marine moisture starting to overspread any cold air that lingers at the surface. European rate here might bring in some cooler air at the surface, as well as the Canadian probably around the same time. Right there, if we can keep some cooler at the surface, although the Canadian possibly hints at some more cold air possibly coming south, but we'll see about that again at this point. And the Canadian model isn't the best at the long range. The German model is what would be most interesting for the Northwest if we stay in some of the cold air. Now, if we look at the same models though, last night, European model from last night. Oops, wrong one. European model from last night kept us in the cold air. We go all the way out to 10 days. Furthest it goes, it kept us in that cold air, moving more cold air into area mid next week. The Canadian did the same, except the Canadian was even colder. Right here, this is the Canadian model from last night, from what's today, Monday, from Sunday night, brought in even colder air than the European did mid next week. So these models even change around the run. Both of these had a stronger ridge off to the west, which allowed for more of that cold air to move south instead of basically connect to other energy to the west. Now, typically, that cold air would not move south. That doesn't mean that it can't happen, but often it will spread out to the west. That happened back um, in December, right before we got the ice. We got a little bit of that cold air at the very end, and that's why Portland got an ice storm. Actually, Seattle did too, because we were able to get some of this moisture from the Pacific that rode up over that cold air, but we didn't get a very prolonged area, very prolonged stretch of cold air. So this is why we have to keep watching the models for all these little details. But we're starting to get a little clear idea for Friday through Sunday morning, with a chance of rain Friday and chance of snow early Saturday. So let's look to see what these models actually do in terms of precipitation. I don't think the German model is on this other website. It is not, but I will, instead of the German model, this other website has the UK map, which is a model that comes from the United Kingdom, and except that it does not have. One second while I'm looking through this. It does not have the same type of map, so I'm not going to go through that. So let me go to. I'm going to a different website, but I'm going to use the same models here. I'm just going to the northwest part of the country. The GFS model, actually the afternoon model just started to run. So I'm going to the morning model, and I'm going to the European on the upper right and the Canadian on the lower left. So let's see what they show for precipitation wise. I'm gonna fast forward to Friday morning because it's basically gonna be dry until then. So on Friday morning, the U.S. model forecasts some rain starting to come into Washington. Same with the European model upper right, and actually the Canadian model in the lower left as well. So all three of those are fairly similar as we go for the day. On Friday, some of that rain starts to move south into northwest Oregon. Now we're at. Oh, I forgot here. U.S. model here is in 3-hour increments, and the other two are on 6-hour increments. Actually, the Canadians also in 3-hour increments. So I'm trying to. synchronized time. Okay, so this is now 4 p.m. on Friday. Now that the first system's coming through, it's going to weaken as it comes through. It's mostly onshore, so it's not going to be a lot of precipitation associated with this. But you see, whatever showers fall on Friday are very likely going to be rain showers. So they go to now 10 p.m. on Friday. So at 10 p.m. Friday, again, we see most of that precipitation is out of the way, unless you look at the Canadian model. We still have some lingering showers, mostly in the mountains, and then up around Olympia. By 4 a.m. on Saturday, again, the Canadian model still wants to squeeze out some more precipitation than the other models. And it's probably because it might be a little more offshore on that first low. I can't remember. I know it was up more offshore on the second low. But now here's that second low starting. This is now on Saturday morning at 10 a.m. on the west coast. This is when we start getting some more of that cold air coming with that second low, that second push of cold air. This is when I think that, or when I thought, just looking at that if we get some development off the northwest Oregon coast, we could start seeing some snow Saturday night into Sunday morning. So we'll see what these models do, just given that development that could push some moisture over that quarter and moving in. So this is what we're going to see. This is Saturday morning at 10 a.m. Increase in moisture, still rain for the lowlands, but some increase in moisture on all three of these. And now at 4 p.m. on Sunday, same thing. Still some rain, maybe some rain snow mix up here around Tacoma into South Seattle, according to the European model. But otherwise, still mostly rain for the lowlands. But we're starting to see, at least on the Canadian model, here we're starting to see that low development off the northwest, actually the southwest Washington coast there, and actually the European still southwest Washington coast, but actually GFS too. But I think all three models were developing even more that night off the northwest Oregon coast. Let's go forward. This is now 10 p.m. on Saturday night, and now we're starting to see some of that low development off the northwest Oregon coast. So this is starting to cool things down. So possibly lowland snow here um, from basically Aurora, Wilsonville up to Olympia, according to the U.S. model. Same thing on the European model here on the upper right. We see this low pressure system. We see a mix with some possible snow here from Aurora, Wilsonville up to Olympia. So it's the same thing there on the U.S. and European models. The Canadian model is a little bit weaker, I guess, with that low, although that doesn't really match what I saw before. But I guess maybe not weaker with low, but maybe weaker with the cold air because it still has some rain at that time. But this is still 10 p.m. I think by the early morning hours might be a better chance here. So let's see, by 4 a.m. only because we still see some colder air. But it's still true. But on the so might see some colder air, but on the U.S. model, that all the moisture is starting to move a little further south. So we're starting to see some of the moisture now basically from Wilsonville south into Eugene area, and it keeps it as snow, both European and the GFS, which the U.S. model. The Canadian model also starts to move a lot of the precipitation south, but still has some light snow over the north, over some of the Portland area on Sunday morning at 4 a.m. Then we get into Sunday, and that low has moved down to the south. So we see on the GFS upper left hand corner, European upper right, and on the Canadian lower left, all that moisture is down to the south. Now the Canadian has some more moisture in California, as is the European. than the U.S. model in the upper right. But by that point, any kind of moisture should be south of us. So the day Sunday would probably look more dry as that moisture has moved out of the area, but we could see some light snow in the lowlands, mostly southwest Washington, northwest Oregon, Sunday night into, Saturday night, January 28th into early morning of Sunday, January 29th. So let's look to see how much snow these three models forecast at that point. And I'm going to use a 10-to-1 ratio, which is not as good as this other one that you saw, which is called the Gutierrez ratio, and that uses basically the most realistic liquid to snow ratio. But I'm not subscribed to Pivotal Weather, so I can't see it on the European model. So I'm just going to look at 10-to-1 so we can compare. So using a 10-to-1 ratio, all three of these models, well, actually not the Canadian. The Canadian model has a little less than an inch of snow in the Portland area. The European and the U.S. model both have like 1 to 3 inches or so, both in Southwest Washington down to about Salem. On the European model, the upper right hand corner here, a little less when you get down to Salem, but still in the 1 to 3 inch in the area. European model, like I said, little less, about an inch, maybe a little less. So we might see some light snow. It wouldn't be anything heavy, and it would be, and again, this is still 1, 2, 3, 4, 5. This is still 5 days out, 5.5 days out from when I'm doing this. But this is if with the second low moving down, if we see that cold air moving in, or I guess really it's going to come through the gorge, and in the Fraser River Gap, we might see some cold air. If we see that low development off the coast, if we can get enough of that cold air moving off the coast, that we get a low development and pull some moisture up, we could see those bands of lowland snow across mostly Olympia down to Salem and Eugene. That kind of looks most likely right now on Saturday night. Again, this is going to change. I'm going to go ahead and pull this back up, only because after that it looks more like onshore flow. So I'm just going to get an idea here of what each of the models might do after that point. So here's the U.S. model. Here's that first low, week low on Friday that moves mostly over land. You see the land right here, the low right here, and so some light showers. It's not going to be cold enough for snow with that first one. But then the second low that comes through here, this is the one that could bring in some cold air in a low development off the northwest Oregon coast and throw some moisture up to get some snow from Olympia down to Eugene on Saturday night, early Sunday morning. After that, now this is the U.S. model that moves that cold air too far to the east. Apparently, it does linger some cold air here at the surface because it does start some of this precip with this next low coming from the Pacific as a little bit of light freezing rain and snow into mid next week until that warm air basically overrides it, although it's keeping some snow for the northwest northwest Washington area with apparently some Fraser River Gap cold still lingering across that whole area. All right, so this is a long range fantasy land. Now I can pull up the same kind of thing for the European model here, but this one doesn't differentiate between rain and snow. This just shows general precipitation. So here on the European model. We see that low off the coast here. This is at 4 p.m. on Saturday, and that's at 10 p.m. Saturday. So we see that low off the Oregon coast, developing off the Oregon coast with that cold air. If you follow those blue lines, that's basically kind of the average temperature from the surface up to about 1,800 feet, roughly. I mean, it's it's the it's actually the thickness of that atmospheric layer, but that's proportional to how cold it is. So this is where we could see some southwest flow, some southerly flow, throwing some moisture up over that cold air that is moving into through the mountain gaps here. And this is where we can start where we can see some snow from Olympia down to Eugene Saturday night into early Sunday morning. Again, this does not show rain versus snow on this website for the European model, and that low moves away. And then through 10 days, European really doesn't have anything else except for where in Northwest Washington this could be snow low level if this cold air is lingering. But you see this warm air, if you look at these red lines, warm air moving to the northwest. So if there's cold air trapped at the lower levels, there could be some snow there. Again, that's this morning's European model. If I look at last night's European model, it's going to look a lot different. You don't see those red lines anymore. You see all these cold, all these blue lines. So it still has cold air over the northwest. So, matter of fact, this one is Monday night. It has another possible system of snow there. This is last night's European model. This morning's European model completely different. So we have to watch all these as we come in. This morning's European was an outlier in terms of European models, but it's starting to match what the U.S. model has been saying for days. But the European model has been very consistent for days too. So it's very possible that they both could go back to what the European model used to say too. So just something we have to watch, and it really is a lot of it has to do with how strong that ridge remains to our west, off off the west coast, extending up into Alaska. All right, the Canadian model. This one you can get rain and snow on, and it has those rain showers Friday. Here's that second low coming down on Saturday, and it just brings a little bit of snow at the very end. That's why it has less than an inch of snow in the Portland area, and that's about it. It doesn't change it over to snow as fast. And then it has another weak system moving south in that flow on Monday night and Tuesday morning with some more light snow on Tuesday morning in the Portland area. And then a warm front coming through on Wednesday morning with some more light snow, starting with light snow. So after Sunday night, Saturday night, early Sunday morning, there are a lot of differences in models that will depend on what happens out in the ocean. This is the German model, and that's this afternoon's run. So this morning's run, here are the rain showers Friday. Here's that colder system coming through. It only has a little bit of light snow at the very end of this in the Portland area. So if it does not change over right away Saturday evening, then we might see just a little light snow at the very tail end of this early Sunday morning. But if it does change over a little sooner, we could get a couple inches of snow here on Saturday night in the Portland area, from Olympia down to Salem or so. All right, that's pretty much it. Let me show you ensembles. So these ensembles are an average of a bunch of different runs of the same model. So this is the ensemble from the Canadian model. It's basically the same model run a whole bunch of times, and then this is just the average of it. So when you see these big ridges and these big troughs in the average, then there's really good agreement that something like this is going to happen. When you see it more, flattened out, as you'll see in the long range, then, well, I'll tell you here in a second. So this is the Canadian model. This is now on Sunday morning. So you see they pretty much agree on that system moving through on Sunday. And that ridge, it's actually fairly strong for an ensemble forecast. So that gives me an idea that um, there could be some cold air lingering here across the northwest into next week. Matter of fact, the average of the Canadian model still has that cold air with a low here by Tuesday night. But as we get further and further into the long range here, you see that this pattern, this is now 16 days away, this pattern is pretty much west to east. So there could be some runs that have like this, there could be some runs that have the opposite, and so when they all average out, they get this average straight west to east. So that's why it gets hard to forecast when we get into the long range. Let's look at the U.S. model average here going into next week. So this is next Tuesday. We still see this ridge here in the west coast, and this cold air is still kind of hanging out in the northwest United States, which indicates to me that the operational run of the GFS may be a little too fast in breaking down that ridge. Now, as I kind of alluded to before, if we get some cold air moving into the northwest and lingering there, any kind of system that moves in from the Pacific Ocean could spread some significant snow into some area if that happens. That's what happened in February of 2019. It happened in February of 2021 when there was a lot of snow from Olympia down to Portland, actually from Seattle down to Portland, and then the southern suburbs of Portland had a big ice storm with all the warm air that moved over that cold air that was trapped to the surface. So this is something that could happen next week as well. It's not off the table. We'll have to see how it plays out. It's still over a week away at this point. European ensembles forecasts show the same thing, except that it actually breaks down that ridge a little faster, which is interesting for the European model. But the average European model still has a low pressure system off the northwest coast here on Monday night and Tuesday morning in that cold air, which is pretty much what the operational European model was suggesting last night. So we could have another system coming through in next Monday night, Tuesday time frame, but again, it's too early to really tell that just because of all the model disagreement. All right, I'm just gonna look at one more thing here. Actually, I could show you two more things. I could show you the long-term climate model, which isn't the best to look at. This model goes out 30 days, so it's more designed to capture long-term climate trends. And this model was actually good at capturing this cold trend, even when I started talking about it, not here via video, but when I started sending out some information to people I know back on January 13th, this climate model was starting to capture this cold pattern coming. So it can capture these long-term patterns a little better. That's what it's kind of designed for. So this is that first low that comes through Friday right there. If you, I'm not going to draw to every single one. This is the one. This is basically the start of that pattern change. You see this big ridge here, and then that first low that comes through here northwest. It's a little further inland. It's not as cold, but I won't draw every single one of these. But this is the second one here. It's colder. It's more offshore. This is the one for Saturday night, early Sunday, and if we get that low development, which on here it looks like we may as well, off the northwest Oregon coast, and that cold air moving in, we could see a little bit of snow. Like I said, from Olympia down to Salem or so. Okay, so and then here's the third one. This is Tuesday now on the climate model. It brings um, it brings some more cold air on Tuesday. That's a little bit too far inland for me without very much on. Sorry, it's a little bit too. Well, when I'm looking for snow, um, that could be a little too far inland. Not enough um, um, trajectory over the water for any kind of low pressure development to bring moisture in. So we'll see about that. But that's what the climate model does: keep cold air into the area in, into midweek, and then it moves that off to the east and moves a ridge in late next week. So I mean these cold snaps don't usually last for a long time anyway. Um, so there you go. And if you 30 days out, February 23rd, it's current forecast pattern, which would just be onshore for price and rain here. All right, but again, that's way in advance. It's going to change, but this is the current cold air that we're looking at. The only thing certain right now is that, well, it's not even certain, but the only thing more likely would be this first event here on Tuesday. What am I saying? Tuesday on Saturday night into Sunday morning. The second one, which will possibly be Monday, Tuesday, is still uncertain, and we don't even know exactly where it's going to go. All right, but if the climate model's right and we get this ridge that builds in here, it'll probably warm up before we get any systems that come off the Pacific. But if we keep cold air in here, um, and some systems undercut this ridge and move into the Pacific while we still have cold air in there, then we could see something else as well. Okay, so the only other thing I was going to go to now is this afternoon's model run, but of the U.S. model, but it's only out for 72 hours. If we compare that to the morning run, I see that this ridge is a little stronger at on Thursday morning than it was in the past run. So what I'm going to do here, I'm going to actually pause this, and you won't notice a break here, but I'm going to pause it, and I'm going to come back to this and when this model's in further. All right, so I'm back. This is the GFS model through 72 hours, which I believe is where I left off. It's now loaded through 234 hours. I just paused it while it was loading, while the new afternoon model was coming in. Now, I will say that I don't use the 60 and the 18Z models that much because they have less upper air data that gets fed directly into them. Because upper air models upper air observations are usually done at 0Z and 12Z, which is midnight and noon in London. And these other two runs don't necessarily have, well, they'll have upper air data in them, but that upper air data will be 6 hours old. So they can sometimes be less accurate. It doesn't mean that they always are. So anyway, I have looked a little bit at this. This is actually trending more toward the European model now. European kind of trending toward the GFS, so if they meet in the middle somewhere, might give us an idea. But here it is now Friday. This is that first system coming through. This is afternoon run of the US model. There's a first system coming through, which is not cold enough for snow. Here is that second system coming through. Now Saturday night and Sunday morning. What's interesting to me on this is that it's not as far offshore as past runs have been. Now that could just be because of an error in the afternoon model. I don't know. It'll probably trend back offshore given every other model run. there is a little bit of a trough that comes off the Oregon coast there, so that might indicate some development off the Oregon coast, which is what I was talking about before. Um, but that's anyway. It's more short. What's interesting of this model is that I can go back a little bit, but this model, in terms of the strength of this ridge offshore, is trending more toward other models. It is a little stronger now than the past models, which keeps this low, this cutoff low, this cooler air back a little further west than in this morning's U.S. model run. Although in the long range, it doesn't seem to really make too much of a difference. It does keep this low pressure system over here from basically connecting with with this next batch of cold air coming down here. It's now Tuesday morning. But the U.S. model pushes that batch of cold air east of the Rockies instead of further south along the west coast, probably because of this ridge actually. So this is why it's so difficult to forecast. Kind of figure out the strength of this ridge, where it's going to move, how this low pressure is going to develop out here out over the ocean. Because the stronger this is, the more warmer it could pull north, and the stronger that ridge could become in the future, even if it weakens a little bit. Because if you look here, that ridge weakens a bit here, but then it kind of maintains its strength here because of this low development here. So this pulls this ridge east into the west coast and forces this cold air to move east of the Rockies, as you'll see as I go forward in time here, right there. So this cold air is forced to move east of the Rockies, and then we get the ridge, and so we don't get into that next batch of cold air according to this afternoon U.S. model next week. So I haven't looked beyond this yet because these just came in, but then it just returns us to onshore flow. Now here, if we have some cold air remaining, I wonder if it brings anything in. So let's look at the surface. I haven't looked at that yet. Let's see what it does at the surface. Again, this is just one run. It's afternoon run for that matter too. So there's the rain Friday. It does still bring a little bit of here's some development. You see the little black circle. So there's a little trough there. So here's some development off of the northwest Oregon coast on Saturday evening. So still has the chance of a light snow Saturday evening into early Sunday morning before that moves south fairly quickly, and then it dries out as the next batch of cold air moves off to the east of the Rockies. That's not what I wanted. I apologize. Here, this next batch of cold air moves east of the Rockies, according to this particular model run, and then it brings in. So it does linger some cold air here though, as we have low pressure offshore, strong high pressure with that cold air east of the Rockies. This is what happened in December, and that allows cold air to move through eastward through the gorge from high to low pressure. And so it actually starts off this next round of precipitation. This next Friday morning as sleet and some freezing rain. It doesn't mean it's going to happen. This is one model solution, but it does start this as sleet, freezing rain, and some snow up in Seattle before changing to presumably all rain. It's not loaded that far out. So that's something that we'll have to watch for, even if the next two just ran. Eventually rains. So that's something else to watch for later next week, if depending on how the flow sets up. So that's what's coming up. The only thing, like I said, for certain, really, it's not even for certain. The most likely thing is that Olympia to Salem chance of light snow coming up on Saturday night into early Sunday morning. And then after that, we just kind of have to watch and see. We still have to watch that too for any details. But right now, it kind of looks like that up to a couple inches of snow. All right, that's it for now. See you next time.